Hey guys, this is Mr. Sal. We're looking at exponent properties together. So we're going to look at the properties from the previous unit or section and just combine some of those rules together. Thanks for watching. Don't forget to like, comment, and subscribe. So in this section, we're just going to be looking at combining these together, all right? So sometimes you'll see a zero power, but then it's also combined with the quotient rule. Or you may see negative exponents combined with the power of a product or power stuff. It doesn't matter. We can work with these. And there's not really a general order of operations when it comes to these rules. So it's going to leave us with, well, some options, which I think is good. All right, like this one right here, okay? So there's a couple ways we could do it, I suppose. The most common way, though, is first to identify the 3 and the 2. I have exponents of 1. And then I'm going to take the 2 and multiply it by all these exponents on the inside. And then I've got to take this 3 and multiply it by all these exponents on the inside as well. And this would be multiplied by the other set of parentheses. It is common for a lot of students to skip this step. Just be careful. As long as we know that the 3 and the 2 bases have exponents of 1 to multiply with those exponents of 2 and 3. So this ends up being 3 to the power of 2, a to the power of 8, b to the power of 10, c to the power of 8, 2 to the power of 3, a to the power of 9, b to the power of 15, and c to the power of 6. So I see we're combining rules here. We did the first rule there by distributing the exponents. Then we can actually evaluate the bases for the base 3 and 2. So that's 9 and 8 right there, multiplied together. 9 times 8 would be 72. So those are kind of out of the way. Otherwise, we've got bases of a, and that's to the power of 8, multiplied by the a to the power of 9, so we'll add those together. And we got a to the power of 17. Then the base b's, I got a power of 10 and 15, so we'll add those together because we're multiplying the bases. So b to the power of 25. And then finally the c base. I've got 8 of them, and then I've also got 6, so that's c to the power of 14. There's our answer. Fully simplified. All right, so we'll simplify these. Now, I suppose this one does require some kind of order of operations. For example, I can't take the 4 and subtract the 8 from those exponents. I've got to simplify that expression first. So what I'm going to do is multiply the 2 and the 4. So that'd be y to the power of 8. And then in the denominator, 7 times 8, that's going to be 56. So I've got y to the power of 8 over y to the power of 56. And then using the rule, this is y to the power of 8 minus 56, which is y to the power of negative 48. Now, generally, they don't want answers in negative exponents, and they should have said that probably on this one. So we're going to make it a fraction and flip it, which makes this y to the, let me take that back, 1 over y to the power of 48. Oh, that's kind of lame. Now, once again on this one, it's just, I don't know why, it just seems like a lot of people just want to divide the 6 and 2 first. But again, just by general order of operations, we got to do the exponents before the division on this thing. So make sure you take care of that exponent first, all right? So for example, that 6 has a power of 1. So I've got to distribute the 5 in first. So that's 6 to the power of 5. Y to the power of 3 times 5 is 15. It's all over, none of that changed in the denominator. Well, you got 6 to the power of 5 over 2. There we go. So we evaluated 6 to the power of 5. Again, nothing else changed on that. So we'll do 7,776 divided by 2, which is 3,300. And then for the y's, I would have y to the power of 15. But we'll subtract those 2 from the denominator, and we get y to the power of 13. All right. Well, we'll have to distribute the 7 into this set of parentheses, and then the 6 into this set of parentheses. I guess I did forget one thing there. The z there in the denominator has an exponent of 1. So what do we end up with? They got x to the power of 4 times 7 is 28. Y to the power of 3 times 7 is 21. And z to the power of 6 times 7 is 42. This is all over. X to the power of 6 times 6 is 36. Y to the power of 3 times 6 is 18. And z to the power of 1 times 6 is 6. So we'll use the rule on this one. I got x to the power of 28 minus 36, which is x to the power of negative 8. Y to the power of 21 minus 18, which is y to the power of 3. And then z to the power of 12 minus, that's 42, sorry, minus 6. Z to the power of 36. Now we have a problem in this though. We got that negative exponent, which we don't want. So we'll make it a fraction and flip it. So in the numerator, these ones would stay. Y to the power of 3, z to the power of 36. But now it's all over that x to the power of 8. And this would be our final answer. Same idea on this one. There's a lot of distribution of these exponents right here. So that's a to the power of negative 2 multiplied by negative 2, which is a to the power of positive 4 now. Then we got b to the power of 4 times negative 2. That's where we're going to run into problems because that now is a negative exponent, which we don't want. So we're going to make that over 1. And we're going to flip that part so the a to the power of 4 stays in the numerator, but the b flips or reciprocates into the denominator, which changes the exponent to a positive. And that's the answer we want right there. All right, simplify this expression using only positive exponents, which is all they really want us to do anyways. All right, so let's simplify the numerator first by distributing the 6 into this set of parentheses to the exponents. And then this negative 3, and that x has a power of 1, so we got to distribute the negative 3 there as well. So that would be x to the power of 24, 4 times 6, and y to the power of 3 times 6 is 18. Now the purple, x to the power of 1 times negative 3 is negative 3, and y to the power of 6 times negative 3 is negative 18. That worked out kind of nice. And this is all over whatever we had before in the denominator. There was nothing to simplify there. So now that we have this, we could continue to simplify the numerator, which is what I would recommend, even though you could kind of combine all this stuff at once. But be careful if you're going to do that, all right? So let's look at the x's in the numerator. I got 24 of them, and then I've got a negative 3 of them. Now those were multiplied together, so I'm adding that. But since I'm adding a negative, it's really the same as subtracting that, right? Which would give me x to the power of 21. So next up, let's focus on the y's in just the numerator. So that's y to the power of 18. And then I've got that other negative 18. And these bases were multiplied. So I end up with y to the power of 0, which, I don't know, seems like it's kind of nice. All of this was over x to the power of 4, y to the power of 3. Well, here's the nice thing about what we have with y to the power of 0. so that's a kind of a combo effect on this, is anything to the power of 0 is 1, so I change that. And I can even change it further by making it a phantom 1. I think that looks better. Well, from here, in terms of y's, I know that y to the power of 3 is going to stay in the denominator. However, the x's, I'm going to take my 21x's in the numerator and subtract the 4 from the denominator. And that gives me x to the power of 17. So this would be our final answer for this one. Now once again we'll simplify this. And we'll use only positive exponents. Well, that negative 2 has a power of 1 right there. So when we multiply this, negative 4 into this set of parentheses, and we do got to be careful with the negative bases like this one as well. I'm going to show this as negative 2 in parentheses. So then I got 1 times the negative 4, so that's a negative 4 there. And we'll get to evaluating that in a moment. But then I've also got x to the power of 4 times negative 4, which is negative 16. Y to the power of negative 2 times negative 4, which would give us a positive 8 there. This is all over, and we did multiply these in the denominator as well. X to the power of 2 times negative 4 is negative 8. Y to the power of 2 times negative 4 is still negative 8. And z also, 2 times negative 4 is negative 8 there. Now we got that z in the denominator. There are no other z's, even though my 2's kind of look like z's, but it's not. So we got to remember not to combine those. But that z is just going to remain there pretty much forever. Well, I take that back. It does have a negative exponent, so we'll have to reciprocate that. But we're not worried about that right now. Let's look at this 2 to the power of negative 4. What I'm going to do is reciprocate that before I evaluate it. So in my fraction, I've got negative 2, and that's to a power now positive 4, because it went from the numerator into the denominator. Some of my students in the past have told me that if it crosses the line, it changes the sign of the exponent. If that helps you, so be it. All right. Some people think it's kind of corny, and I don't really care either way as long as it helps. Okay. Looking at the x's on this, in the numerator I got x to the power of negative 16. Then I would subtract the exponent of x in the denominator, so minus negative 8. And this is where we run into trouble, because we subtracted a negative. So some people just want to make it minus 8. Well, we got to remember it's minus negative 8 on that. So that ends up being plus. And so that would be x to the power of negative 8. I'm going to keep it in the numerator for now, just so I can acknowledge that it was x to the power of negative 8. You don't have to do this. You could have put it in the denominator right away, and it would have crossed the line, so you would have changed the sign. But whatever. The y's are going to work the same way. We've got y to the power of 8, and then I would subtract this negative 8 exponent in the denominator, which makes that plus, so that ends up being y to the power of 16. The z didn't change, so I'm going to keep that as a negative exponent in the denominator, just knowing that I still need to simplify this. So what do we get out of all this? Well, some stuff is going to flip. The y's aren't, so that's going to stay because it's already a positive exponent. There are no other y's. The x's can flip though. So I'm going to change the x's into the denominator. The exponent crossed the line, so I change the sign. And negative 2 to the power 4 would be negative 2 times negative 2 times negative 2 times negative 2, which is positive 16. The z also is going to flip into the numerator because it had a negative exponent. It crossed the line, so I changed the sign. And it looks like we did it. So again, we simplify this only with positive exponents. But we've only got one negative to distribute into this parentheses, which I think it's kind of good. However, there are two directions we can go, and that's to use kind of what we've been doing on this. So I'm going to do this two different ways, actually. Now, the first way I'm going to do it is to distribute this negative 3 into all the parentheses. All the exponents inside the parentheses. So that would be a to the power of negative 15, b to the power of positive 12, all over a to the power of negative 12 times b to the power of negative 12. So using our exponent rules, I would have a to the power of negative 15 minus negative 12, which is a to the power of negative 3. And then the b's, b to the power of 12 minus negative 12. Now that's kind of ugly there. Negative 12. So minus negative makes that plus, and we get b to the power of 24. Then, of course, we would reciprocate the a to the power of negative 3, and this would be b to the power of 24 over a to the power of 3. The other way to do this would be to go back, and instead of distributing the negative 3 first, you can distribute it after you simplify whatever's on the inside of that set of parentheses right there. So, still a set of parentheses. We're going to keep that negative 3 exponent. But then I would have a to the power of 5 minus 4, and b to the power of negative 4 minus 4, which would be a to the power of negative 1, b to the power of negative 8, and this is all to the power of negative 3. So it's at this point that I would distribute this negative 3 into the parentheses to get a to the power of, that wasn't looking right, that's a positive 1 right there in red, a to the power of negative 3 times b to the power of positive 24, and we end up with the same expression that we had right here, which will give us this final answer anyways.